my favorite part of this unit was inverses. So with this inverse section, I added some of my favorite cartoons I used to watch as a kid that they've made into live movies throughout the last few years. One of my most favorite cartoons to watch when I was little was Transformers. So here's Optimus Prime, and he's saying graphing inverses are more than meets the eye. And it's true. Graphing an inverse is not simply just graphing it, but actually graphing it and seeing how it changes and how it relates to the line y equals x. So remember to always draw the line y equals x. So even before you start, draw that line. And I know mine are a little crooked, but draw the line, because what your goal is to see is if your graph reflects over that line. So these are both m and b graphs. So I'm going to go m equals negative 2/3 and b equals negative 2. So I count down negative 2 and count down 2 over 3. Down 2 over 3. And that's just about enough of what I need. So I'm just going to draw my line. Make sure that your line always has arrows on it. So I'm going to pick 3 points from here. 3, 4, 5, as many as you feel you need. That will give you a good inverse. Alright, so I am here at 0, negative 2. Even though my graph looks like it's at 0, negative 1. Let's start over. You know, these graphs that we make for you, they're so small, so it's hard to see the middle. Here we go. Alright, so I have a point here at 0, negative 2. So you make your t-table. Then I have one here at 3, negative 4. And then this one here is at 6, negative 6. So for inverse, you're just going to reverse the numbers. So negative 2, 0, negative 4, 3, and negative 6, 6. So I'm just going to go to negative 2, 0. Negative 4, 3. And negative 6, 6. Okay, so now all we need to do is see if our line has a reflection with these dots. And if you turn your head a little bit, you'll see, yes, that these dots are a reflection. Alright, let's take a look at the next one. The next one, we're supposed to start at m equals 1/4, b equals negative 1. So we go down to negative 1 and go up 1 over 4. Up 1 over 4. Oops, I have no more room, so I'll go the other way. Down 1, left 4. Remember, if you don't have enough room, you can always go the other way. So these points that I get are negative 4, negative 5, negative 2. Negative 4, negative 2, sorry. 0, negative 1. And it looks like 4, 0. So my new graph, you just change the numbers around. So -2, -4, -1, 0, and 0, 4. So as you can see clearly, these dots are reflections over that line. So these are our inverses. Alright, do you know what this cartoon is? I bet you don't. Anyone who watches the video that can tell me this, the name of this cartoon, write it at the top of your paper. So you might have to ask your parents the name of this cartoon, because I don't know if they show it on cable. Alright, this is a parabola. You're going to have to go to your y equals in your calculator, type the x button, then the x squared button, plus 2. Okay, I'm going to show you how to do that because I do have a virtual calculator on here. Alright, well, here is the calculator. So you go to your y equals button. You go to your x squared is right there, plus 2. Enter. And then you press graph so you can see what the graph looks like. And that's what your graph should look like. Then you go to second graph and look at the table. And as you can see, these numbers are kind of big. So I'm going to go up a little bit. And if you look right around here, you'll see right here there are some numbers that you can use. And you'll see there's a pattern. It goes 6, 3, 2, and then 3, 6. So those are the 5 numbers that you want to use. So I have -2, 6. It always likes to disappear. -1, 3, 0, 2, 1, 3, and 2, 6. And then for my inverse graph, I'm just going to switch those numbers around. Any idea what this cartoon is yet? Alright, so there goes your points from the calculator. So just to go back, you can see what the graph is supposed to look like. So I'm going to graph my first one first. And please extend your lines. I had to take off points for several papers because you guys stopped at the dots. Don't stop. Extend your lines and draw the arrows. Okay, now I'm going to draw my y equals x line so I can look for the reflection. And then I'm going to draw the next line. So the blue line represents the inverse, the pink represents the original, and then I'm just going to show you how they reflect over that line. So those are the reflections. These reflect. These reflect. Sometimes it's a little harder to see when they're further away. These are direct reflections. This is a long but direct reflection. Almost looks 3D. So that's it. Alright, the next one, you're going to do the same thing, except instead of it being x squared plus something, it's x squared minus. So x squared minus 1, go to graph so you can see what it's supposed to look like, and then go to second graph, and you want to be able to pick some numbers that you can use. And as you can see, it goes 8, that's a little too high, 3, 0, -1, then it goes back to 0, and then 3. So we can probably use these numbers here. So I'm going to start at -2 and end at 2. Now for my inverse, I'm just going to switch them around. These questions you should get right with no problem, because all you're doing is just picking points from your calculator and switching them around. So here is your original. Please make sure you draw arrows and you extend your graph. Draw your line going through the middle so you can see the reflection, and then draw your other graph. Okay, I made a mistake with that one right there. So now if I look for my reflection, these are reflections. Those are shared points. That's a shared point. Let's see. 0, 1, and 1, 0. These are reflection points. These are reflection points. So everything kind of matches up as a reflection over that line. Alright? Alright, so that ends the graphing portion. So these are some of my favorite 80s cartoons, and they do show a lot of them on Hub. I don't know what channel Hub is, but Hub shows these, so I always get a little nostalgic. I used to love He-Man, Jem and the Holograms, and G.I. Joe. All three of my favorite cartoons to watch. So whenever I catch them on Hub, I always get really excited. Alright, so back to math. Verifying. Verifying means that f of g of x equals g of f of x, and they both equal x. That's your verification. So that is how I'd like to see it on a test. So we want to do the f of g of x first. So we want to take this value and replace it for x. So f of g of x means f of 5x plus 10. So that means we start off with 1/5, replace the x with 5x plus 10, then minus 2. So notice everything looks the same as this except for the x part. Now we're going to distribute. 1/5 of 5 is just 1x. 1/5 of 10 is like 10 divided by 5, which is 2. Minus 2, these combined become 0. 1x plus 0 is just simply x. So far we're on a good roll. Now for the other part, g of f of x, we want to take this and replace it for x down there. That's called the g of f of x. So we are looking for the g of 1/5 x minus 2. So we take that 5, still put it in the front, replace the x with 1/5 x minus 2, and then end it with plus 10. So 1/5 of 5 is 1x. 5 times -2 is -10, plus 10 from here comes back. Combine your like terms, it's 1x plus 0, which is just simply x. Since both of your answers came out to be x, we say that yes, this is an inverse. And the reason is our verification that I wrote at the top. F of g of x equals g of f of x, and they both equal x. That is what I want you to do. I do not want you to switch the x and the y here. Please stop doing that, because you're going to get points off your test. Alright, we're going to do the same thing here. We're going to take the 2/3 x plus 6 and replace it for x. So that's f of g of x. So f of 2/3 x plus 6, we take that 3/2, Replace the 2/3 plus 6 in for x, and then plus 4. 3/2 times 2/3 cancels out, and you're left with x. 3/2 times 6 is really 3 times 6, which is, let me show that we're distributing. So 3 times 6 is 18, divided by 2 is 9. Then bring down the plus 4. So when we combine like terms, we get x plus 13. Automatically, we should see that something is not adding up. So now we do the g of f of x. That means we take this piece and replace it for x in here. So now we have the g of 3/2 x plus 4. So we have 2/3 times 3/2 x plus 4, and all of it is going to be plus 6. So 2/3 times 3/2 just gives you x. 2/3 times 4 is the same thing as 2 times 4, which is 8, divided by 3, which is 8/3, or 2.666666. Who wants to write all that? Plus 6. Well, 8/3 plus 6 is definitely not going to cancel out, and it really is just going to give you another ugly fraction, which winds up being 26/3. So x plus 13 and x plus 26/3 are not even equal, but the more important thing is they're not equal to x. So we would say no, because f of g of x is not equal to g of f of x, and they're both not equal to x. Remember, this is the main thing that you want them to be equal to. Even if they both came out to be x plus 13, they can't be inverses. They have to be x, because it's all based off of the line y equals x. Alright? So G.I. Joe, Jem, He-Man. Yay! Alright, last page, and we are finished. All-time favorite 80s cartoon ever was the Smurfs. I used to love the Smurfs. Love them, love them, love them. But I refuse to see the live movie because it really looked kind of stupid. So I'm nostalgic for what is good. If it's good, keep it the same. Alright, so f of x equals 9 minus x. What we want to do is find the inverse. So the first thing you want to do is switch the x and the y. So this is already y. And now you want to solve for y. You want to get this by itself. So the first thing that we always do usually is get rid of the number. So we do minus 9. So x minus 9 equals negative y. Bring the negative with the y. That's really equal to negative 1. So most of you probably kept the answer as x minus 9 over negative 1. But you can divide things into negative 1. So x divided by negative 1 becomes negative x. And negative 9 divided by negative 1 becomes positive 9. And that is your answer. So please make sure you try to simplify as much as you can. You can leave it as a fraction if it's an actual number, but if it's 1 or negative 1, carry it through. Alright, next one, x minus 3 over 7. This is already y, so we switch the x and the y. The only way to get rid of a denominator of 7 is to multiply by 7. That's the only way that these will cancel out. If you multiply 7 on the right, you have to multiply 7 on the left. So now I have 7x, because 7 times x is 7x equals y minus 3. So we're going to add 3 on both sides. These are not like terms, so it's not 10x. Do not put 10x. Don't put 10x. I'm going to say it like 5 times. No 10x. Instead, you just write what you see, which is 7x plus 3. Alright, last question. Let me make some room here. We have 2x squared plus 1. So first thing you want to do is switch the x and the y. Solve for y by doing -1 on both sides. And do x minus 1 equals 2y squared. Well, we want that y squared by itself, so we divide by 2. And now we have y squared equals x minus 1 over 2. Okay, you don't have to do anything with that 2. You don't have to carry it through. I just carried this through because it was -1. So the only way to get rid of a square is to do the square roots. So square root both sides. But remember, guys, when you take a square root, you have two possibilities. A positive square root and a negative. So you have to write plus or minus x minus 1 over 2. You probably never heard that before, but you are hearing it now. Always put a plus or minus when you take a square root. So because I physically drew this square root, you should put a plus minus. Alright, that ends our review. I hope this review helps you. The test is on Tuesday, so you have the opportunity to watch this video all weekend, and you have the opportunity to watch the video on Monday night. Alright, good luck. I want everybody to get an A, B, or C. Alright, so if you don't feel that confident, please come in for help. I am here Monday for you at lunch. Alright, good luck. Just like my little smiley says, go for it. Good luck. I know you guys can do it.